Let's see the next question. At time t is equals to 0, a particle starts to move along the x-axis. If its kinetic energy increases uniformly with time t, the net force acting on it must be proportional to. So I know that, so the particle is starting from the rest, and again you can say that it increases in proportion. So then we can say over here, so the kinetic energy is proportional to your time t. So this you can say that, so this ke is equals to b into t. Again further, so what is the further thing we can say? So kinetic energy is half mv square, so half mv square is equals to b into t. So then the next thing, mv square is equals to 2bt, so v square is equals to 2bt upon m. Then again I can say, so for this particular case over here, so this is nothing but, let's say, ct. So v is equals to, again I can say, square root of ct over here. So this is what I can say. So again I can know that your force is equals to mass into acceleration. Again acceleration is dv by dt. So d by dt of, obviously that is a c root t. So that c is root c is constant obviously. So you can say acceleration is proportional to, obviously you can say that 1 upon 2 root t. So that is what we can say for this particular case. And again force is equals to mass into acceleration. So you can say that, so that is a mass, and again that is acceleration. So where we just said that it is obviously proportional to 1 upon 2 root t. So in short you can say finally F is proportional to 1 upon root t over here. So your option D is correct for this particular case over here. Let's see the next question over here. A stone is tied to a string of a length L, is wheeled in a vertical circle with the other end of the string at the center. At a certain instant of time, the stone is at its lowest position. So you can say that at a certain instant it is at its lowest position. Then you can say that it has a speed u over here. The magnitude of change in its velocity when it reaches when the string is horizontal. Yeah, so then definitely you can say that again when the string is horizontal over here. So for this case now it becomes horizontal over here. So now you have to just, so you have to just find the difference between that is, so the string is horizontal, the magnitude of change in its velocity which we have to calculate over here. So initially you can say that, so that is your initial over here. So the energy is nothing but the kinetic energy half mv square. Then you can say that, so this is nothing but your mgl again plus your half your mv square. So let's say this is u, okay, and this is nothing but your v over here. So even I can write it down the same thing. So this is your, again I can say, so that is a half mv square minus mgl is equals to half your mv square. So you can say, so from this particular case over here, so also get cancelled. So this is your half u square minus your gl. So this is your half, again that is you can say for this particular case over here. So this is your v square. So since we had just cancelled that your m, so this is your v square. So u square minus 2gl, again which is nothing but equivalent to v square. So if I just take, even I can write it down in the magnitude form, that is a vector form also. So this is a u square minus 2gl, again that is a, let's say, along the j cap over here, and the initial you can say that, obviously you can say that, so that is a u into I cap, so which is moving along that your horizontal axis. So the change in the magnitude of your velocity, so then definitely you can say, so for this particular case over here, so definitely again if we just do the calculation, so that is a change in the magnitude for this particular case over here. So you will get simply, so that is your change in the velocity of your magnitude. So this is u square minus 2gl over here. And again, for this particular case also, we can just simplify over here. So you can write it down. So that is a u square minus 2gl plus u square. So that is a change in the magnitude. So we can say that. So this is your 2u square minus 2gl. Again, you can take 2 common. So that is a 2 into u square minus gl over here. So that is what we can say. Then for this particular case, so 2 into that is a u square minus gl. So your option C is correct.